Okay, we're going to be talking about seafood before some of you go out and eat it, and most of this is pretty big scale. I'd like to say, first of all, that when you think about seafood, there's some common questions that come to mind frequently. One of them is and I'm going to be addressing some of them, but not all of them. What is it? What's that catch? Where did it come from? Which is often very problematic. Is it safe? Yeah, did its capture or production hurt the marine environment? Which is difficult to address if you don't know the first ones. And will there be enough of it for all of us in the future? Now, seafood, of course, is solar powered. It's because, like all the biological generation, well, most of it anyway, it comes from the marine environment. It comes from solar powered primary production. And there are some places on Earth, luckier than Australia, where everything comes together to produce a huge amount of marine productivity. And we harvest that from various levels in the food pyramid, which we'll get to in a minute. Most of you already know all about that. And that all of us know this as well, that life's efficiency is not perfect. And even though the oceans are large and the resource is large, it is nevertheless finite, and we are trying to share it with everything else in the ocean that's dependent on it, either directly or indirectly. So we start with the sun, huge input, but finite, and it comes in, and where things work out properly, we get our primary productivity in the world's oceans, the hotter colors, particularly whether you get the wonderful upwellings where the ingredients for life are mixed with the sunlight. And this somewhat drives, of course, all of the marine life that we take part of. So we have the classic food web or food pyramid, very broad at the bottom, where the primary producers are. The sun's input comes in there, and it goes through each trophic level up through the pyramid, and of course it's narrowing. There's less biomass and there's less energy. Every time there's a trophic change, every time something eats something else, there's energy lost. And here is an example of a marine food web from Tasmanian coast. At the bottom we have the primary producers, and everything flows generally uphill here toward the top, and the animals at the very top of the food web include things like mammals and seabirds, etc. And we are, of course, taking our bits at various levels on the way through. So we take what I would say is our pound of flesh. This is a cross-section of the ocean. And the elephant in the room, generally speaking, about almost everything we've been talking about today, is the population projections, which vary somewhat in the future, but have that general shape that we all worry about. And we certainly have the capacity to ramp it up. Arguably, we've already taken our share of marine production. If you look at the productivity required and you calculate based on some transfer efficiency between trophic levels, you can work out for all the seafood that we extract from the system what part of the primary productivity in each area would be required to produce that. And the hotter the colors, the greater the proportion of the primary productivity that we have taken out in the 1950s on the top and 2005 on the lower image. We can also look at this sort of as a source and sink, in this case, source and consumption. We can look at the 1950s and the 2000s on the left-hand side. We can look at all the exclusive economic zone claims for countries around the world and what proportion of the primary productivity in those areas that is taken out as seafood. And of course, seafood is one of the most traded commodities on Earth. So it's consumed not necessarily by those countries. It's consumed on a per capita basis on the graphs to the right-hand side in the 60s and the early 2000s. And the hotter colors there are greater seafood consumption. So as it were, it's starting from those exclusive economic zones and with tuna stocks, et cetera, further offshore, and it's being shipped off to consumers in those various countries, including, of course, being shipped from Australia and to Australia. And that's one of the things that we've been trying to look at. I would say we're at the 101 level of trying on a global basis to find out where the seafood that goes to various consumers comes from, whether it be farmed in agriculture or whether it be wild caught. Now, looking at some wild caught seafoods, on the right-hand side, we got the Canary Current in the 70s and the 90s. And what we're doing is trying to connect the dots between where that yellow area just off the northwest coast of Africa, the Canary Current, and where it actually flows to in some of the ports around the world. And the same with the Humboldt Current of South America on the right-hand side, again in the 70s and the 90s. We're interested in improving this to be able to find out where it's going from, to be able to say that seafood that you've made a decision to consume started there, and this is its provenance, and this is what the kind of impacts it might have had. And this works both for Australia positively as well. When we talk about our well-managed fisheries, we can put this in context as well. It's a bit like the certification idea, but we're basically trying to do this with all fisheries, and you don't have to pay to join. But Australia has what I'd call regional pressures. Specifically, we've looked at global fisheries effort and the change over time. We've just recently revisited this for FAO, United Nations. And the trend is that in the Asian region in particular, there's been a huge increase in the effective effort, the amount of energy that goes into fishing. As it were, this is fossil fuel-based power to take fish. And we're in a region, we're on the cusp of a region at least, where some of the biggest changes are occurring. This is one of the Chinese fleets going out for the day. You get enormous fishing powers around the world, and of course, those countries that couldn't contain their needs within their own waters are, of course, using the waters of other countries, and have always used the high seas as soon as that became safe and profitable to do so. This is some work that we completed not too long ago. Looking at panel A on the top left, it shows you the distance that and this is the minimum mean distance that the seafood has traveled from where it's been taken or produced in an agriculture farm and to where it's being consumed. This has been going up steadily. Panel B on the top right shows you the area of the world's oceans that we're using for these wild captures and the level of intensity based on proportion of primary productivity, red being the highest, 30%, to green sitting on top of it at 10%. This is going up. The area is going up and the intensification is going up. Panel C shows the global pressure. This is in the accessible areas. These are areas that are under 1,000 meters of depth, and how much the primary productivity in those areas have we started to sequester for our own uses. But D is the important part. D is the seafood consumption that's gone on since 1950s, and the projection of it based on population scenarios. There's also these horizontal lines which show you, based on the current ways in which wild capture is used to support the mariculture of fish species, how much fish production we could reach under various scenarios, whether it be 20% of the fish, the feed that's gone into the aquacultures is from wild capture, or 10%. And of course, we can push this eventually to the point where we're not using any wild fish, and then arguably we're probably not making seafood anymore, but we are making protein, of course. So what we've learned from these various studies, that seafood is being sourced from further away. The area of the oceans that's being used is increasing and is intensifying. The projected demands, we argue, can't be met without changing agriculture methods. This is being re-echoed and revisited by many people now, without significant changes to marine systems. As in, you could make them into eutrophied farmyards. But, although that seems rather grim, don't panic, because with some other work we've been doing, we've been revisiting how we've been going historically. And basically, these are two of the longest historical stocks we've got records for, and you can see for the cod on the left-hand side goes from the 1500s, and from about 1100 for the herring on the right-hand side. The green area is the numbers of fish in the sea. Well, we are talking about numbers here. It's a long story, but you'd have to read the paper to find out why. And the orange line is the cumulative extraction that we've taken in numbers from the sea. What we were basically doing is seeing how we've been going historically and at what point we've actually taken more of it from the sea than is left in it at this time. This is an interesting graph that Simon Jennings came up with, and it based itself on the Rand-Myers stock assessment database. Each of those strands of flowing wheat is a separate stock that's been assessed for many years, except time as it runs from left to right isn't time as we know it, it's in generations of the fish. And the vertical axis is the ratio between the amount that we've taken out from that stock out of the sea compared to the original amount, the virgin biomass, the unfished biomass. So at which point we've crossed that, we've actually taken it over and over again. Now, the point of this is twofold. One is that we shouldn't despair, because historically we have been able to fish for hundreds of years, and we can do it right. But the other one is, if you look at the strands of the bullets on the strands, they represent the state of the stock. Basically, how much does the biomass over the virgin biomass, the biomass over the BMSY. So the blue ones are good, green is not so good, and red is, we have a little bit of a problem here. And of course, the wheat strands bending downward also means we've slowed our rate of taking it. But if you looked at some of those strands, you'll see that some of them have flip-flopped in color. We have been able to recover some of them. So it's not all doom and gloom. We have been able to fish for centuries, and we have been able to recover stocks. And now this is something that Dave's been all over, but I'll go through it very quickly, and I call it follow the fish. So, and it's 100 million tons, not 100 tons, that's taken globally. This is the wild fish catch, basically rounded without dealing with unreported catches, etc. Of which about 65%, and I think Dave has a bit higher, but 65% is eaten directly, and about up to 35% can be turned into fish meal. And I guess we haven't talked about that too much directly, but basically ground up for meal, for protein, and for oil, but not typically, people don't have a fish meal sandwich. It typically goes into other things. But one of the things we deal with here in Tasmania is about 33% of that fish meal at least goes into feed for animals like salmon, etc. And all in all, fish form at least 15% of the diet of people. But of course, that fish meal goes into other things. And you'd be surprised how much of it goes into pet food when you start trying to trace seafood coming into Australia, how much of it's coming in as pet food. It goes into fertilizers, probably less so than it used to. It's used in feeds for beef and the milk production, pork, but I would argue that the big comer now is the chicken. You know, you can't feed a chicken more than about apparently 6 or 7% fish meal before it starts to taste like a fish. And yes, I think they used to when I first arrived in Australia. But chickens are little powerhouses in terms of they don't produce too many of those nasty gases. You can stack them up, you've got the area to do it. But we've come to be very reliant on them. There's 100 million tons of them produced, 1 trillion eggs, and there's 3 of them for every one of us. And 33% of the protein that is actually coming from chickens now. So arguably, if you were looking at where is this fish going, where the demand's going to be, who's competing with us for eating it directly, it would be basically going through the chicken system, we'd say, or in some cases clawing it back so it's direct human consumption. I'm just going to finish with some crazy projections. Some of them you will like, some of them you'll hate. I think that fish meal and fish oils from the wild landings will continue to be important for animal feeds for years to come, although it's partly price-based. That geoengineering, I think it will be attempted. We attempt many other things without consensus, and whether it's been done to modify climate, to make droughts, and this will have implications, and we're still looking at those. The aquaculture, the people tell me, could go more into GM, even GM bacteria. And they could be moved more onshore, arguably. I would say that, and have said to reviewers, that if you take it inshore and you don't feed it anything from the sea anymore, it's not really seafood anymore, is it? So it's not part of my publication. But basically bringing it onto the land, closed systems, that natural seafoods that we enjoy now will of necessity, given that population curve, be very limited per capita. You'll probably get a choice whether you want natural or GM, or we'll get to the next point in a minute. The high energy inundated coasts, this is just a crazy idea of mine. So if you have to fall back from the American East Coast because you can't put the levees up there, why don't you try and generate some energy in those areas, given that you're going to have high energy storm surges anyway, but maybe you can make it into some sort of marine food production area. And Stuart, here's your autonomous platforms that will produce food and power at sea, and they can even submerge when there's a storm coming. I'm sure we're probably on the cusp of that right now. Unfortunately, I think, going back to the food choices, we might have to rethink food. We're all afraid of this one. We remember the movie Soylent Green. I don't suggest that we're going to be using Soylent Green, but I think there was a Soylent Red or something that was made from algae and other things. And I think that all marine areas, unfortunately, for those that want them wild, will probably be used for food production and desalination and energy production. And those that have flown over places like Indonesia will have seen that water world is already here, basically, in terms of their talking about aquaculture. It's very hard to distinguish where the land is from the sea in some of these areas. Perhaps that's the future. Anyway, I think it's time for us to have a conversation and start making some decisions about our future. Thank you.